Hey, it's Mr. Rain going over Precalculus Chapter 1 tests taken 9/26/2018. This is versions F and H. Question number 1, the function y equals f of x is reflected in the y-axis. So reflected in the y-axis, your graph is this way. The mirror is right here, so therefore reflected on this side. That's when the negative is on the inside, so these two, and then translated down, this is -5, but that's on the outside. That would be choice D. Question number 2, evaluate the piecewise function. I told you guys didn't have to use this. It says f of -6, so if you put your x value right there, right, question number 2 says evaluate the piecewise function, and if you put function notation f of x, you'll recognize that your x value is -6. What does this tell us? When you have a graph, there's two parts of this piecewise function. You're looking for the one where x is -6. So, question, if you put in -6 here, is -6 bigger than -5? That would be false, so the graph wouldn't be there. If you put in -6 here, -6 is less than or equal to -5. Therefore, you put in -6 here. -6 plus 2 is -4. Opposite of -4 is +4. Show you how to put that in your calculator. Clear that out. I'm going to put in this one in parentheses, so let me go ahead and draw some parentheses for you. We're going to put that here. We're going to put a division sign, and then no if part, but the inequality we will. So parentheses x plus 2 divided by parentheses x, that's the variable button. Inequality sign is going to be in your second math, and then you have the inequalities there, so you're going to pick greater than, -5, come down here, parentheses negative x plus 2, close the parentheses, second pair of parentheses divided by second math, x is less than or equal to -5. Oh, no x here. Okay, zoom 6. So here's a picture of our graph. Let's try to make this super color coded for you. The one that has the negative slope is in red. Notice how that's x values that are less than -5 going that direction. And the one that has positive slope is the blue one. We know that the red doesn't show it to you, but there is a closed circle, and so at -6 you're trying to evaluate that, and you just go up to at -6 and we'll get an answer of 4. Now if you go to your table, second table, and you go down to -6, you'll recognize again in blue there's an error, right? You can't put it in there because it's false, then you get an answer of 4. So that's why your answer is 4. Okay, question number 3. Given the graph, write the name of the basic function in the first blank, and then the equation or function in the second one. I wasn't looking for the exact one but if you're recognizing here, it's starting here at 0. This is a square root. Function, or also be acceptable if you wrote radical. So that's 1 point, and then the equation is just f of x equals the square root of x. And if you need to double check that with the visual, go y equals, clear those out. Then the square root button is here in blue. then I'm going to have to press the blue button first. So second, and you know second has an arrow, then the radical sign, X, zoom 6. If you want to get super fancy, you can put the negative in there. So second, delete, you put the negative, and that's your graph. Question number 4 says graph the following function. So I'm going to put that in my calculator. X cubed plus 8x squared plus 14x plus 4. Zoom 6. Okay, so I have too much here on the positive x value, so I'm going to change my x max to maybe 3. I need to make my y values higher, so I'm going to guess maybe 30. So go to Window, x max we set 3, y max we set 30, and then y scale is just how many times the tick mark is counting, so I'm going to count by 5s. And then don't press zoom 6. Zoom 6 puts it back at negative 10, 10, negative 10, 10, so I'm just going to press graph. There's a nice looking graph. I'm going to go ahead and sketch that, but leave your calculator there. Okay. From here, the question is talking about identify intervals in which the function is increasing, decreasing, or constant. Use the above graph to answer the questions. Identify intervals. Well, that just kind of hints out to interval notation. And you guys did this before on your quizzes. So I'm just going to find a local minimum. The reason why it is a maximum is because the mountain goes higher and there is a taller maximum height. And this would be a local min. So the number one mistake here is students probably just press trace and then they're trying to estimate it. And what happens there is the graph, if you're just doing this, it's not precise enough. So if you go to second trace, which is the calculate button, go down to max number 4, and then left bound means to the left of the graph, so get the arrow left of the mountain, go towards the right, and when it says guess, you're going to try to get exactly, and then the calculator is going to look for you that coordinate. So I'm going to round to the nearest tenth, negative 4.23, comma 12.2. And then the local minimum, second trace, minimum number 3. I'm already to the left of this point, so I can just press enter and then go all the way to the right. And then guess whatever I think the minimum is. And this gives me negative 1.10, comma, negative 3.05. Okay, no more calculator needed. Where's the graph increasing? Increasing is where's the roller coaster going up? So here in yellow, this is where my roller coaster is going up. Now, you are looking at the y values to determine in some ways that it's increasing. But when you're writing it down, you're just looking at the x values. So you write down just the x values. So I have from negative infinity, that's the arrow. Again, it's not because it's pointing towards down, but it's just the graph keeps going left, so all the negative numbers. Let's write our infinities here, maybe that'll help you. And then we're stopping here at an x value of negative 4.23. Now the reason why it's parentheses is because you cannot include any particular number in negative infinity, and then this here is negative, and it is a parentheses because you don't include this. We were saying that at the top of the roller coaster it's not going up, no, it's going down. You're kind of just sitting there sometimes. Now in this graph there is two parts of the graph where it is increasing, so we're going to do union at negative 1.10 to the last thing you touch is an arrow. Regardless if it's going up or down, it's going towards, we're focusing on this axis, so that would be positive infinity. Where is the graph decreasing? Well, it's going down between these 2 points. So you can say between negative 4.23 and negative 1.10. Now the word constant means if there was like a piecewise function and maybe your graph looks something like this, something crazy, and it was straight, that would be the constant part that we're talking about. So there's a couple of answers I would accept for full credit for this part right here in purple. You could say it's constant at x equals negative 4.23. You could say at negative 1.10, or you can also say none. So either these x values or the word none would give you full credit for 1 point. And is the graph continuous? The answer is yes, because I don't have to pick up my pen to draw this graph. So that's question number 4A, B, C, and D, and E. Your softball team is ordering equipment from a catalog. Each is like per, or this would be your slope. The cost of the shipping is $12 no matter how much you order. So this is your starting point. You're going to have to pay that. That's your Y-intercept. So this is your M. We said this was your B. No matter how much you order, the total cost is $348. So we can call that our Y. How many bats does the team have to order? Let's color code that. So we said this was 42. The keyword is each per bat, so it doesn't matter. Charge you 42. X is the number of bats we're going to order. My Y value is the total cost. It's going to be 348. And then my starting point for the problem is my shipping. It's always going to cost $12 total. So if I subtract 12, I get 336 equals 42x divided by 42 on both sides. Then we can order eight bats. And that would be choice A is our answer. Question number 6. In question number 6, well, the free response, make sure to show all your work in the box provided. Number 6, given f of x equals 2x squared minus 5 and g of x equals x minus 3, find the following below along with their domain. So if you just draw yourself a quick graph of 2x squared minus 5. The graph is going to be shifted down 5 units. And then g of x is x minus 3. Linear, shifted down. The big idea for a domain is that in the pink here, your domain is going to be all real numbers, which is essentially negative, infinity, and positive. How do I know that? Anytime you have two arrows at the beginning, one arrow, so you're going left to right. What does it mean? You can pick these negative numbers, you can pick these positive values, so you can pick all real numbers. Same thing with this one. And in interval notation, that's negative infinity to positive infinity. We're going to need that later on. So when you add just f plus g, let's just color code these. You're going to put the f here. For question 6b, you're going to subtract those, so pay attention to the subtraction sign. This one looks like it's multiplication, and then f, you're going to divide. Our g there, you're going to add. G, you're going to subtract, multiply, and this one, divide. So 2x squared minus 5 plus x minus 3. Well, with the plus sign, you don't have to, you don't need the parentheses. You can drop them and just combine like terms. So you got 2x squared plus x, and then That becomes minus 8 with the domain of negative infinity to positive infinity. What does that mean? You kind of just look for the most restrictive. Well, in this problem, it's kind of easy. They're both saying you can pick all real numbers, so you have some very carefree parents. They say you can do whatever you want. They trust you. You're an adult. So this would be the most restrictive domain. Question 6b. 2x squared minus 5, my substitution, and then minus x minus 3. Now, the negative sign, your parentheses, is needed because you're going to have to change the operations there. 2x squared minus 5, negative x plus 3. And then just combine like terms, 2x squared minus x minus 2. And then your domain will be negative infinity and positive infinity. It says you can pick all the values of x in the f function, the g function, and then when you put them together, you can still pick that. Question 6. Okay, there's no math operation there, so it's multiplying. 2x squared minus 5, x minus 3. So I'm going to do the box. 2x squared minus 5, x minus 3. So I multiply those and get 2x cubed. Negative 5x, negative 6x squared, positive 15, so I get 2x cubed. Writing this in descending order by the exponents, so there's a 3, there's a 2, there's a 1, negative 5x plus 15. And then our domain would be negative infinity to positive infinity. Okay, question number 6. This one has division, so we have to pay attention to this one. 2x squared minus 5 all over x minus 3. Now here, we're looking at the domain. The domain are the x values. What numbers can I pick? Well, there's certain numbers you cannot pick. Remember, you cannot divide by 0, and so that's why we set the denominator not equal to 0. And basically you can't pick 3. So what is our answer? Our answer is in pink and green. 2x squared minus 5 over x minus 3 with the rational function. And basically, if you use integral notation to pick every number except for 3, I didn't state, so you can also do set builder notation if you wanted to, but integral notation is great. That's question number 6. Alright, question number 7. I keep switching it up to keep you on your toes. Determine the symmetry. Symmetry is just referring to is it kind of mirrored or imaged over the y-axis? Is it rotated around the origin, or is it neither? Now, students commonly get confused. This is not, even though last year I said on that you should know how to do inverse. This is not the inverse. This does not mean take the vertical line test that passes and take the horizontal line test passes, and then you switch your x's and y's and then solve for y and then put inverse of x. That's not this problem. So again, it says algebraically explain, and then so what we're going to do is for every x sub in negative x. So do the problem. F of negative x equals negative x squared minus 2x minus 1. Whoops, got to put a negative x there. And remember, you're using PEMDAS to simplify one side of an equation. Negative x times negative x minus 2 times negative x minus 1. So that would become x squared plus 2x minus 1. Now, they look the same, but they're not because of that plus and minus sign. So it is not equal to the original. So it's not, what does that mean? Not even. If I factor out a negative 1, this would be negative 2x plus 1. And then here, can you sub in, can you write x squared minus 2x minus 1? Can you write f of x there? The answer is no. So this is not equal to the opposite of the original, so it's not odd. The answer is if it's not odd, it's not even, then the answer it is neither. Why? Because it's not even, not odd. Okay, how do you do that graphically? You just graph it. It's quadratic. Shift it up. Sorry, shift it down 1 unit. So it doesn't have symmetry about the y-axis. It's not rotated about the origin, so I like to think of it as this was rotated 180 degrees. So in this quadrant, do you have a tree sticking kind of straight down? The answer would be no. So no. Not even, which is symmetrical about the y-axis. Not odd, symmetrical about, odd stands for origin, comma, so it is neither, or not even, not odd. Question number 9, find the x and y-intercepts for the following function. To find a x-intercept, you're going to make y equal to 0. There is no y here, so that is your y. 0 equals 4x plus 2 over x minus 1. To make 0 a fraction, I'm going to put it over 1, and then I'm going to cross multiply. Now, when you're cross multiplying, kind of keep those as chunks. 0 times anything gives you 0. Let me color code this for you. You multiply these two, you get 0. And if you get 1 times this, it's just this. So 4x plus 2. And then there I can just solve for x. Subtract 2. And then divided by 4. This is negative 1 times 2. 2 times 2. Your 2's cancel. X is equal to negative 1/2. Which gives you the order pair of negative 1/2 comma 0. Question number, the next part is you need to find the y-intercept, which means we're going to find every x value 0. If you ever forget, super conceptual, you're taking the SATs tomorrow, like one of my students just told me, I like to just make a graph and then say, well, an x-intercept is where it touches the x-axis, and if you make up an order pair, 3, 0, that means your y value is 0. Or if you make an order pair down here, let's just say that is 0, negative 5, so in a y-intercept, the graph is the x value. You have to make x 0. So let's make x 0. Four times 0 is 0, 0 plus 2 is 2, 0 minus 1 is negative 1, so you get y equals negative 2. And then if you get an order pair, you're going to get 0, negative 2. Question number 10, we're going to graph this. It says make sure to include your asymptotes. We've talked about how to show that algebraically. So the vertical asymptote, you're going to set the denominator not equal to 0. So x cannot equal 1. For the horizontal asymptotes, you're going to have compare the highest exponent of both the top and the bottom. So here is a 1, and here is a 1. so 1 and 1, then you're going to put equals, so that tells you in your rule, your chart, to reduce. What does it mean to reduce? You have 4x over x. Well, these x's will cancel and you're left with just that. So your answer is y equals 4. You have a horizontal asymptote at y equals 4. Okay, table of values. Table of values. Okay, so the table of values, you're asking, where do I start? Well, if you're going to have a vertical asymptote at 1, I meant to give you guys some nice graph paper in here, but it didn't work out, so just deal with it. Okay, so here's my really quick graph. And I want to show you this visual of the vertical asymptote. So if I put a graph at 1, vertical line, I put it dotted. It's not a vertical line actually, but it just shows you a visual. So this should give you an idea that the graph is separated into 2. 1 into 2. Now if I make the middle of my table of values 1, I basically want to know numbers that are smaller than 1. 0, negative 1, negative 2. And I want values bigger than 1. 2, 3, 4. And you can kind of see the visual, numbers to the right, numbers to the right, numbers to the left. And you could just substitute those numbers in, but I'll let you guys use your calculator, so I'll just put in this function. 2 ways of putting this in. I'll put in the first way, old school. Parentheses first. 4x plus 2 divided by, delete, x minus 1. Second way, to prove that they're equivalent, because they'll just graph on top of each other, you press alpha and then F1, or y equals. And it brings up this window here, and basically that is the numerator and denominator, top and the bottom of the fraction. 4x plus 2, and you press down, x minus 1, and if you ever need to write something to the right of it, you just press right. You got it. Let's press zoom 6. Now the goal wasn't to just take the graph from the graphing calculator, but to get the table. So second table, and you can see how the graph changed colors to show that those two that I wrote were exactly the same. And what did I want to show you? Oh, table set. So second window to make sure the table set's correct. Doesn't matter what number it is. You can start near 0. The vertical asymptote will be fine. Counting by ones is great. This one says automatically, calculator automatically figure out the x values, and you want to automatically figure out the y values. So I'm pressing second graph. There it is. Those numbers are exactly the same. And so I'm just going to write down those numbers. Set 2, I have 10, I have negative 2. Negative 2 is 2, negative 1 is 1, 0 is negative 2, and 1 we already know that it is a error, or that essentially means undefined, where we can't divide by 0. And at 2 you have 10, 3 you have 7, and then 4 you have 6. So let's go ahead and graph those. my best to zoom in. Let's put on all those other puzzle pieces. Sorry, let's zoom back out. Let's get the x-intercept. Negative 1/2, 0. So somewhere around here. 0, negative 2. 0, negative 2. And then my horizontal asymptote at y equals 4. 3, 4. Okay, so with the pink and the greens, the vertical and horizontals, now you have kind of like 4 areas. 1, 2, 3, 4. And the table of values helps us understand if the graph is above the horizontal asymptote or below. Watch. Negative 2, 2. Negative 2, 2. So notice how it is below. So that means my graph is going to, all my graphing points should be in this little area. Negative 1, 1. Negative 1, 1. And then 0, negative 2, which we already have. And then on the other side of the pink line, our graph should either be above or below. 2, 10, so I should verify it is above. Something way over there. 3, 7, something like that, and then 4, 6. I don't even have enough, but it gives you the idea. 1, 2, 3, 4. Whoops, should be like that. Somewhere there, and then 4, 6, maybe something like that. So I can already see that my graph. Take a pencil. I only use pen to kind of help you guys see it. And that's it. That's how you graph the rational function there.